Hello everyone, this is class 12 subject chemistry chapter 4 lecture number 5. In this lecture we will be discussing our next topic, that is colloids, classification of colloids, mechanism of micelle formation, and in the end of this lecture I will be discussing the homework that I gave you in lecture number 4. Now next topic is colloids. So first of all we need to understand what are colloids. As we have discussed in unit 1, that is solutions, that solution are the homogeneous systems, and we also know that sand in water when mixed gives us a suspension. In between solution, true solution and suspension, we have one more type of solution, that is colloidal solution. So first of all I am discussing the differences between true solution, colloids and suspension, and after that we will discuss what are colloids. So first of all, first difference is the nature. So the nature of true solution is homogeneous, that is the concentration is same throughout the solution. In colloidal solution and suspension, these two solutions are heterogeneous system. Heterogeneous means concentration is not uniform. Next is about the particle size. So in true solution, the size of the particles is less than 1 nanometer, whereas in colloidal solution, the particle size lies between 1 nanometer to 1000 nanometer, and in suspension, the size of the particle is more than 1000 nanometer. Next property is filtrability. So the particles of true solution, they can pass through ordinary filter paper as well as through membrane. Whereas in case of colloidal solution, the particles, they can pass through ordinary filter paper but not through animal membrane. Whereas in case of suspension, the particles, they do not pass through filter paper as well as through animal membrane. Next property is settling. So the particles of the true solution, they do not settle. Same with colloidal solution, the particles do not settle. But in case of suspension, the particles, they settle on standing. Example is when we mix sand in water. After some time, the sand, it settles down at the bottom. Next is visibility. So in case of true solution, the particles are invisible. Whereas in case of colloidal solution, the particles, they can be observed under ultra microscope. And in case of suspension, the particles are clearly visible to naked eyes. So these are the 5 differences between true solution, colloidal solution and suspension. Now after that we will define what is colloid. So from here we can conclude that colloid is a heterogeneous system, and just as in solution we have solute and solvent, in case of colloid we have dispersed phase and dispersion medium. Next property is these colloidal particles have enormous surface area, that is they has large surface area, and because of large surface area, some special properties of colloids to be discussed in this unit. So from here we can see that colloidal state of matter is therefore a state in which the size of a particle is between 1 nanometer to 1000 nanometer, and the particles, they can pass through ordinary filter paper but not through animal membrane. Now the next topic is classification of colloids. So there are 3 classification of colloids. Now I will be discussing one by one all the 3 classifications. So first classification of colloid is on the basis of physical state of dispersed phase and dispersion medium. So on the basis of physical state of dispersed phase and dispersion medium, colloids are classified into 8 types, that is 8 colloidal systems are possible. So first type of colloid is when the dispersed phase is solid and the dispersion medium is solid. That type of colloid is known as solid sol. And the example is gemstone. So when the dispersed phase and dispersion medium both are solid, that is the type of colloid is known as solid sol. Next is when the dispersed phase is solid and the dispersion medium is liquid. Now that type of colloid is known as sol. The name given for that is sol. Example is paints. Third is when the dispersed phase is solid and the dispersion medium is gas, that is known as aerosol. And the example is dust. So in dust, dispersed phase is solid and the dispersion medium is gas. Now fourth is when the dispersed phase is liquid and the dispersion medium is also solid. That example is known as gel. Next is when the dispersed phase is liquid and the dispersion medium is solid. The type of colloid is gel and the example is butter. Now next is when the dispersed phase is liquid and the dispersion medium is also liquid, then that is known as emulsion and the example of emulsion is milk. Next type is when the dispersed phase is liquid and the dispersion medium is gas, that is known as aerosol. The name of the colloid is known as aerosol and the example is cloud. Cloud are the example of aerosol. Next is when the dispersed phase is gas and the dispersion medium is solid. So that type of colloid is known as solid sol. Example is pumic stone. Eighth is when the dispersed phase is gas and the dispersion medium is liquid, that is known as foam and the example is froth. So these are the 8 type of colloids when the dispersed phase is gas and the dispersion medium is also gas. That forms a homogeneous mixture, that is why that type of colloid is not possible. So we have 8 type of colloid depending on the dispersed phase and dispersion medium, and the name is also given. So on the basis of physical state of dispersed phase and dispersion medium, 8 type of colloids are possible. Now next is when the dispersion medium is water, then that is known as aquasol or hydrosol. And if the dispersion medium is alcohol, that is known as alkosol. So these are the 8 type of colloid. Among these 8 types, the sol, emulsion, these are the common types, and in this unit we will discuss about sols and emulsions. Now next classification is on the nature of interaction between dispersed phase and dispersion medium. So on the basis of interaction between dispersed phase and dispersion medium, colloids are classified into 2 types, that is lyophilic colloids and lyophobic colloids. So first of all, what do you mean by lyophilic? Lyophilic means liquid loving. Lyophobic, liquid hating. And when the dispersion medium is water, then this lyophilic will become hydrophilic and this lyophobic will become hydrophobic. Now one by one we will discuss all the points in lyophilic colloids and in lyophobic colloids. So first is, what are lyophilic colloids? So first is, the word lyophilic means liquid loving, and these type of colloids, they can be prepared directly by mixing substances like gum, gelatin into water, that is into a suitable liquid. So these lyophilic colloids are liquid loving, and we can prepare lyophilic colloids by directly mixing with dispersion medium. For example, if we want to prepare the lyophilic colloids of gum, so simply we will mix in a suitable dispersion medium, we will get lyophilic colloids. Whereas if we talk about lyophobic colloids, so lyophobic colloids are liquid hating and these cannot be prepared directly. Some special methods are applied for the preparation of lyophobic colloids. Next point is that lyophilic colloids, they are reversible in nature. Next point is lyophilic colloids are reversible in nature. That is, if the dispersion medium is separated from the dispersed phase, let's say by evaporation, the sol can be reconstituted by simply remixing with the dispersion medium. For example, if we mix starch in water, we will get lyophilic colloids of starch in water. But suppose by evaporation, if we remove water and after that we will get starch and water, that is, we can separate starch from water. But again, if we mix that starch in water, we will get lyophilic colloids. That is, we can reverse this process. That is why lyophilic colloids are reversible in nature. Whereas lyophobic colloids, they are irreversible in nature, means once we get lyophobic colloids, we cannot separate dispersed phase and dispersed medium. Next point is, these lyophilic colloids or these lyophobic sols are quite stable. Whereas in case of lyophobic colloids, we need stabilizing agent. Example is solution of starch, gelatin in water is the example of lyophilic colloids, and in case of lyophobic colloids, metals and their sulfides. They cannot be directly prepared. Some special methods are to be applied for the preparation of these type of sols. So these are the 5 differences between lyophilic colloids and lyophobic colloids. So on the basis of nature of interaction between dispersed phase and dispersed medium, colloids are classified into 2 types, that is lyophilic colloids and lyophobic colloids. Lyophilic means liquid loving, lyophobic means liquid hating. Now on moving to the next classification, that is third classification of colloids, is on the basis of type of particles of dispersed phase. So the third classification of colloid is on the basis of type of particles of dispersed phase. Now in this classification we have three types, that is multimolecular colloids, macromolecular colloids and associated colloids. So one by one we will discuss these 3 types. So first is multimolecular colloids. So when we mix these type of multimolecular molecules in a particular dispersion medium, so what happens, a large number of atoms or smaller molecules of substance aggregate together to form species having the size in the colloidal range. As we know that size of colloidal particle is in between 1 nanometer to 1000 nanometer. So what happen in case of multimolecular colloid, a large number of atoms or smaller molecules, they will form aggregate and together to form the species having the size in the colloidal range, that is the size lies between the 1 nanometer to 1000 nanometer. Example is gold sol. Next is macromolecular colloids. Now some naturally occurring macromolecules are like starch and cellulose. When these substances, these are macromolecules, that is they have big size molecules and having large molecular masses, that is when the substances having big size molecules called macromolecules having large molar masses are dissolved in a suitable liquid. So when these macromolecules are dissolved in a suitable liquid, or you can say a suitable dispersion medium, they form a solution in which the molecules have size in the colloidal range. Means these macromolecules, they will break themselves into the colloidal particle size range, that is in between 1 nanometer to 1000 nanometer. Next is third type of colloid is associated colloids. Now there are some substances which when dissolved in a medium at low concentration, they will behave as normal strong electrolyte. But at higher concentration, they exhibit colloidal state properties, that is the size of the particles lies between 1 nanometer to 1000 nanometer. This is due to the formation of aggregates and these type of colloids are known as associated colloids. Now micelle formation is the example of associated colloids. Now micelle formation, it will take place only above a particular temperature, and for the micelle formation there is a particular concentration above which only it can form. So the temperature above which micelles can form, that is known as Kraft temperature, and the concentration corresponding to that micelle formation, that is known as critical micelle concentration. So in associated colloids, soaps and detergents micelle formation is the example of associated colloids. So on the basis of type of particles of the dispersed phase, we have 3 types of colloid: multimolecular colloid, macromolecular colloid and associated colloid. In multimolecular colloids, a large number of atoms aggregate so that the size of the particles lies between 1 nanometer to 1000 nanometer. Whereas in case of macromolecular colloids, the macromolecules, they will break themselves in a suitable dispersion medium so that the size of the particles lies between colloidal range. And third is associated colloids. These type of colloids, they will behave as normal strong electrolyte in low concentration, but when we increase the concentration they form aggregates, and the size of the aggregates lies between colloidal range, that is 1 nanometer to 1000 nanometer. So these are the three classification of colloids. Now we will discuss the mechanism of micelle formation and the cleansing action of soap. So next topic is mechanism of micelle formation. Now let us take the example of soap solution to understand the mechanism of micelle formation. Now first of all we need to understand what is soap. So soap is a sodium or potassium salt of higher fatty acid, and the formula is RCO negative Na positive, where this R is organic part, the CO negative, this is polar part, and when we dissolve soap in water, the CO negative and Na positive, they will separate into the water. Now let us take the example of sodium stearate, which is a major component in many soaps. So the formula for sodium stearate is CH3CH216 CO negative Na positive. Now here we have long chain of hydrocarbon, and this dotted black line shows the hydrophobic part, that is the non-polar part which is present in the soap, whereas the CO negative, this is the hydrophilic part, that is the water loving part, and this is the polar part. So this polar part will interact with the water when we dissolve soap in water. Now from here, if we want to represent in the head and tail, so this circle represents the hydrophilic head which interact with the water, whereas this tail, this represents the long chain hydrocarbon, that is hydrophobic part. So this is the head of the soap, this is the tail. Now what happens when we dissolve soap in water at lower concentration? So in lower concentration, this polar part, that is the CO negative part present on the surface, that is this head, will interact with the water, whereas this tail, this will remain on the surface, that is away from this water. When we increase the concentration of soap in water, that is when we increase the concentration of stearate ion, so at critical micelle concentration, the anions are pulled into the bulk of the solution and they aggregate to form a spherical shape with their hydrocarbon pointing inwards, and the polar part will project on the surface of the sphere. And this type of aggregate formed is known as micelle. So in this first diagram, this is the arrangement of stearate ion on the surface of water at lower concentration of soap, that is when the concentration is low. This polar part, this negative represents the polar part that will interact with the water, whereas this hydrocarbon, it will remain on the surface, that is away from this surface. But when we increase the concentration, that is at critical micelle concentration, they will take a shape of sphere, where this tail, it will be inside the sphere, and this negative part, it is on the surface of the sphere, and the aggregation results in the formation of micelles. Similar mechanism will take place in detergents. So now next we will discuss the cleansing action of soap. So as we have discussed the mechanism of micelle formation, now micelle consists of hydrophobic part as well as hydrophilic part, whereas the hydrophobic part, it will lie in the center, and this hydrophilic part, it is on the surface. Now the cleansing action of soap is due to the fact that soap molecules form micelles around the oil droplet in such a way that hydrophobic parts interact with the grease, whereas the hydrophilic part interacts with the water. That is, suppose this is the grease which is present on the piece of cloth. Now when we apply soap, what will happen? The negative part, or you can say the polar part will interact with the water, whereas the hydrophobic part, it will interact with the grease. So the soap molecules form micelle around the droplet in such a way that hydrophobic part of the stearate ions is in the oil droplet, and the this hydrophilic part projects out of the grease droplet like bristles. Since the polar part, this negative polar part, will interact with the water, the oil droplet surrounded by the stearate ion is now pulled into the water and removed from the dirty surface. That is, micelle formation will take place, and when we wash with water, these micelles are washed away with water and we will get our surface free from the grease. So this is the cleansing action of soap. In next lecture, we will discuss the preparation of colloid, purification of colloids, and the properties of colloidal solution. So after doing this topic, you can solve NCERT exercise question number 9th, 11th, 12th, 14th, 25th and 26th. So this is all about cleansing action of soap and mechanism of micelle formation. So now I will be discussing the questions that I gave you in lecture number 4. So first question is, why it is necessary to remove carbon monoxide when ammonia is obtained in Haber process? So the answer for this question is that this carbon monoxide, it will act as a poison for the catalyst that we used in Haber process. In Haber process, iron is used as a catalyst. So this Cu, it will act as a poison and it will reduce the activity of the catalyst. That is why it is necessary to remove CO when ammonia is obtained in Haber process. Next question is, why is the ester hydrolysis slow in the beginning and becomes faster after some time? The answer for this question is that ester hydrolysis leads to the product, that is, when we do the ester hydrolysis, acid and alcohol is formed. So the acid produced in the reaction, that will act as a catalyst for this reaction, and therefore the reaction becomes faster after some time. Third question is, what is the role of desorption in the process of catalysis? So desorption is removal of product from the surface of the adsorbent. So desorption makes the surface of the solid catalyst free for the fresh adsorption of the reactant on the surface. That is, when desorption will take place, the surface of the catalyst will free and therefore new reactant molecule can adsorb on the surface of the catalyst. Next question is, what are enzymes? Write in a brief mechanism of enzyme catalysis. So enzymes are biochemical catalysts and the mechanism is lock and key mechanism. That is, in first step, at the active site of the enzyme substrate complex, it will form enzyme substrate complex, and after that second step is dissociation of enzyme complex to form the product. That is, in next step, second step, the enzyme substrate complex, it will dissociate and we will get our product. Fifth question is, what is shape selective catalysis? This we have already discussed during the lecture. Catalysis by zeolites is called shape selective catalysis. So the catalysis which is done by zeolite, that is known as shape selective catalysis. So these are the 5 questions. In next lecture we will do our next topic, that is preparation of colloids.